Hi there guys, we are on worksheet 2, part 2, and we are going to be focusing on getting this cylinder or number 3 completed. Right, let's start by using my line tool and selecting the correct line type so that I could go and find and project the necessary lines, which will give me the width of the cube that I'm going to be using to fit my shape into. Just remember, I always say that all shapes could fit into their own boxes. So let's go and create this box in which this shape is going to fit. Alright, I'm simply going to be projecting down and across from my existing cubes, as all these cubes are exactly the same size on this worksheet. And yet again, I'm going to be using my 30-degree set square, in this case my computer, to draw my 30-degree lines. You might notice that I'm typing in 330 degrees. The computer reads 360 minus 30. So my lines will still meet up to be 30 degrees. It's just going in the other direction. Okay, I can either continue drawing 30-degree lines, or I can simply go and copy these lines which have the correct length and the correct angle. In this case here, I'm going to select this line and I'm going to use the copy tool. I'm going to copy using this. In fact, let's try this again. This portion here is going to line up with the top corner. And that point over there is going to line up with that top corner. I'd like to just highlight something. An isometric cube will be a perfect hexagon. Alright. So if you're stuck and you don't know how to draw an isometric cube, you should just try drawing a hexagon, and you'll manage to draw a cube. Right, I'm going to be using my 30-degree line again from this point. Yet again, confused with the direction in which it's going. Therefore, I use the 330 degrees from this point on. Or I can simply take this line and copy it to that point. Right, now that I've constructed my isometric cube, I know that I'm going to be dealing with a cylinder, and the cylinder has an isometric circle on the top surface, and we also have an isometric circle on the inside of that isometric circle. Let's go ahead and construct the top isometric circle. I've got the correct line selected, and I'm going to go from my obtuse angle to opposite center. Yet again, go from my obtuse angle to my opposite center, creating this V. Obtuse angle to opposite center. Obtuse angle to opposite center. Right, and now we have a V in the opposite direction. I'm going to be using the intersection points of these two V's to give me the arc. You might notice that I have an entire isometric circle, not like we have in number 1 or number 2, where we only use portions of the isometric circle to complete our drawing. Go to my arc tool to the intersecting points. Right, there's something wrong here. Let's try that again. Make sure that you get the intersecting point. That looks better. There we go. Just remember, you are drawing your arc from and to in between these two V lines over here. Let's do the other side. And let's make these two line types a final line so we can actually see them nice and dark. There we go. Alright. We're going to use our arc tool again to go from the obtuse angle, and we're going to join this point quite obviously to that point over there. Nice and neatly. And we're going to use this arc tool on the opposite obtuse angle to join that point to this point here. Great. Let's select these two lines and change the line types to a more prominent line so we can actually view our isometric circle. The bottom surface of the cylinder would obviously be making use of some of the isometric circles and also portions of those arcs. So let's see how we're going to go about completing the cylinder first before we focus on the inside circle. Because this is an exact cube, we know that these lines will automatically be drawn at 30 degrees. At those intersecting points, and we can simply go and construct our isometric circle at the bottom surface. Yet again, we have that V that we've spoken about before. We're going from obtuse angle to opposite center. Obtuse angle to opposite center. And these construction lines will then yet again provide me the intersecting points to use to draw my arcs. Right, I'm going to use a construction line because I don't know which portion of this isometric circle is going to be in final line, so I'm going to suggest you use your best construction line. Obtuse to opposites. Completing the one half or the one end, and to the other end. Right, now we need to decide which of these arcs I'm going to be making a nice prominent line so that I could actually view my entire cylinder as a final object. Use my line tool, still in construction line. I'm not going to simply draw the longest line I can draw within that isometric square. Note that this line is longer than a line that I would draw from obtuse angle to obtuse angle. The acute angle to acute angle will then definitely give me my longest line. I'm going to do the same on the bottom surface. And I'm going to rely on where the arc touches this line to join this point to where the arc touches that line. Use my line tool. To join those two arcs or circles. And let's change those two lines to more prominent lines. There we go. Alright, now it's starting to take shape. I now know that I need to make this arc a more solid line. And I know that I'm only going to be using a portion of this arc. This portion over here that's going to the back end of the actual cylinder, I'm not going to be able to see from this angle. So I'm going to use my trim tool to simply trim it, and same to the other side. And I'm going to select these two arcs and make them final line. Try that again. There we go. Right, we've found our initial cylinder, and now the next step will be to find the smaller cylinder, or a cylindrical hole that runs right through this cylinder. What I'm going to do is I'm simply going to be constructing lines, making use of these lines, right down through to the bottom drawing, just so that I know which parameter I'm working with. And it's also a simple checking point for me to see that I'm going in the right direction. Right. Now what's very important is there are many ways to do this. I can either project the sizes, like I have started doing here already, down to the bottom, or I can simply go and draw the entire isometric square in which this isometric circle is going to be fitting. Let's see how I would go about doing this. I'm going to select a center line, and I'm going to be joining that point over there to this point over here, which is theoretically at 30 degrees. I'm going to do the same from this side. Let's see, to that side. This will give me a nice indication of where the center of the entire object is, since they are sharing centers, that is the inside and outside circle or isometric circle. I can go ahead and go and project this center right down, which should be in line with my isometric cube. Looks like I have a line down there already. That's the one there. I can use that. And I want to mimic those center lines in my bottom drawing as well. From there to there. And from here to here. As you can see, they do meet up perfectly. Alright. So how are we going to go about doing this? Let's make these a little bit darker so we know where we're working from. I will have perfect reference points on my or from my center lines. The first reference point is we know that I'll be drawing an arc from one V to the next, which is from here right across to here. And on the inside, I now have to go ahead and draw. Let's try that again. At an angle of 30 degrees from the center line. Some reference points. Lovely. Right, I now also want an angle of 30 degrees to the opposite direction. So I use the 330 degrees that SolidWorks allows me to use, because it's 360 degrees minus 30 to give it to a different direction. So where the center line touches my isometric circle, I create a reference point on the isometric box. Right, I'd like to highlight what I've done. These are the lines I've used. In fact, I'm going to make it a little bit more distinctive. There it is there. The light blue lines, that will form the box in which the isometric circle, the smaller isometric circle, will be fitting inside of my larger isometric circle. Those have reference points on my outside or parameter, and I can use those reference points projected straight down onto the isometric square or cube down the bottom over here to form exactly the same square I have in this shape here down the bottom here. Let's go ahead and do that. I know that these 2 points are going to be in line, so I'm simply going to be going from this point over here. Let's make sure they are 100% straight so that I have accurate points to work with. This point over here goes through that point. Go. And already I can start drawing lines. I am missing a couple of reference points though, but let's try an angle of 30 degrees from the point referenced on my outside cube or the parameter to the opposite side. I'm going to do the same with the other side. Got 2 lines, and I'm going to draw 30-degree lines in the opposite direction from this point here. And these points here projected onto the actual isometric box. Right, so I'd like to highlight the 2 boxes or the similarities. I've used these lines to create my box in which the isometric circle is going to fit, which is the same as this box that I'm highlighting for you right now. Right, there we go. If you wanted to, in SolidWorks, you could simply have copied these lines, used the reference point, and plotted it straight down the bottom here. In your case, you'll have a TD board in front of you, and you'll be using a 30-degree set square. This is why I referenced these points, so that you could simply project those points down onto the actual parameter and use those reference points to be able to find this inside box, which is obviously going to be drawn using 30-degree lines. Okay, just remember, if you are confused, you could always go back into the video and replay this part so that it does make sense to you eventually. Alright, so now that I have an isometric box to work with, I need isometric circle construction. I'm going to use my line tool again. I'd like to highlight the box that I'm using so it's easy to view. Just change that line type for a moment. There's the box. And I'm simply going to go from my obtuse angle to opposite center. Now the lovely thing about having center lines is we know that this object is, or the two isometric circles are sharing the same center, which means we have the center line providing the center of the opposite line automatically. So simply go ahead and I create that line, and I go to the opposite center. Remember, obtuse to opposite centers will create that inside V. Please take note that there was an isometric circle construction already used for a bigger circle, and now we're using a new isometric circle construction for a smaller circle. We cannot use the same isometric circle construction because it's meant for a bigger circle on the outside. Okay, using my line tool yet again, I'm going to go to the obtuse angle to opposite center, and obtuse angle to opposite center. Quickly highlight those points or intersecting points I'm going to be using. There they are over there. I'm simply going to be using those intersecting points to provide me a new arc, which is obviously going to be a lot smaller than the one on the outside. I'll go to my arc tool, go to the intersecting point, I open up to the parameter, I click. In your case, you'll be putting your compass on the intersecting point. You're going to be opening it up to the parameter to draw your arc. Similarly, yet again, I'm going to be going to the intersecting point. You're going to be putting your compass point over here, and you're going to be opening it up to the parameter, and you're going to simply draw your arc from and to. In this case here, I'd like to quickly change the line type of those two arcs. There we go. And I'm going to use my arc tool again on the actual obtuse angle to opposite centers. To join the one point of the isometric circle to the other. Opposite obtuse angle to opposite center. To simply join the 2 points forming my isometric circle. Right, let's change these two line types. And I'm going to now simply fade away the original isometric square I needed to draw my inside isometric circle. Take that back to construction. Right, there we are. Take note how I've made use of center lines. It's very important. It is actually important to have center lines on every one of these isometric circles so that you know exactly that these isometric circles are in fact sharing the same center. In this case here, I don't need them. I'm going to be taking them away. But in fact, you will need to keep those isometric center lines there. Please take note that that is obviously at 30 degrees. Right, thank you for joining me for Worksheet 2 Part 2.